All right, in this video, I'm going to go through page 5, which is the last page of the study guide, and catch the rest of the problems. So problem number 22 and problem number 23, solve each inequality, graph it, write the answer in interval notation. So these two problems, 22 and 23, are not absolute value inequalities. So you don't need to do any kind of split. Just solve these like you would a regular inequality, regular equation even, and just worry if you at some point divide by a negative number, you will need to flip the inequality sign. Now, in this problem, I just added 12. Okay, 4x is less than 12. Divided both sides by 4. Now, since I was dividing by 4, there is no reason to flip the inequality. This is your solution. X is less than 3. It says to graph the solution. So on my handy dandy number line, I'm going to put a 3, and I'm going to shade less than 3. There's no equal to here, so there's a parentheses. So my interval would start at negative infinity, go to positive 3. I am done with problem number 22. Okay, so we solved it, we graphed it, we wrote the answer in interval notation. All right, over on number 23 here, there's a couple of different ways to solve this problem. You could absolutely take negative 3, distribute here and here to get rid of the parentheses. I'm actually just going to go ahead and divide everything by negative 3. Now, I did just say that I'm dividing by a negative. So instead of now it being less than or equal to, I'm going to flip that inequality sign, and it is greater than or equal to positive 2. I'm going to add 5 to both sides. So x is greater than or equal to 7 here. So I have a solution. Let's go ahead and graph it. So on my number line, I need number 7, greater than, shades to the right, and this is going to be a bracket. So 7 to infinity, 7 takes the bracket, parentheses, of course, for the infinities. All right, so problem number 23 is done. So number 22 and 23, they're just linear inequalities. There's nothing extra special about them. Just make sure that when you are solving these, solve them like any equation. And just if you multiply or divide by a negative, you will need to take out or just flip the inequality sign. Okay. All right. 24 and 25 are your exponential equations. So taking a look at number 24 here, what I want to notice is what do these two things both have in common? Because right now we don't have the any kind of a subtraction rule for exponents. So what I can do though, and I notice that I have 2x here and I have 2x here. So I'm going to go ahead and factor out a 3 to the 2x. So if I take out 3 to the 2x here, I would be left with 3 to the first. And if I factor out 3 to the 2x here, I'd be left with 1 because that's 3 to the 2x divided by 3 to the 2x. So that's 486. Let's see. 3 to the first minus 1. Well, that's 3 minus 1 is, well, it's 2. So we've got 3 to the 2x times 2 equals 486. So I am going to divide both sides by 2. So let's see. 486 divided by 2 makes... Did I write something down wrong here? No, I didn't. Oh, it's to the 3. Never mind. My brain was doing something it wasn't supposed to be doing. So 243. Oops, not trying to cancel that out. All right, so now I have a base 3 on this side. My brain was trying to get this to be a base 2, and I was like, that's not going to work. It's not going to work for base 2, but 243 is 3 to the 5th. So 3 to the 2x equals 3 to the 5th. Now that I've got the same bases, and I actually can make base 3's work here, we're going to ignore the bases and just set the exponents equal. So x is equal to 5/2. So for these problems, you have to be able to create the same bases. If you cannot create the same bases, then something probably went wrong with the math. Okay. All right. So there's all the bits, parts, and pieces to number 24, dealing with that exponential problem. I'm going to slide over to problem number 25 and approach it pretty much the same way. Right? What do they have in common? So if I notice, oh, I've got 4 to the x here. I've got 4, whoops. That highlighted a bit more than I wanted it to. So x here, 4 to the x here. So I'm going to factor out that 4 to the x. So that's going to leave behind 4 squared plus 1 equals 136. So let's see, 4 to the x times 17 equals 136. So what is 136 divided by 17? That's 8. All right, so let's see, we've got 4 to the x is equal to 8. Now you might be looking going, wait a minute, Curtin, didn't you just say I have to get the same base? And I've got a base 4 here, and I'm not going to be able to turn 8 into a base 4. You would be absolutely correct. But in this case, we're actually going to change both bases. 4 can be rewritten as 2 squared, and 8 can be written as 2 cubed. So this actually turns into 2 to the 2x equals 2 to the third. And if I drop in those like bases, I get 2x is equal to 3, which of course means that x is equal to 3/2. Okay, so again, there's all the bits, parts, and pieces for number 25. Same kind of setup as number 24, with the only exception that when you got to this little line here in green, 4 to the x equals 8, you had to change both bases. And sometimes that'll happen. Okay, but again, we were able to get it to be the same base on both sides, so we are able to then solve it. All right, so that's 24 and 25. Our next little set of problems here says to use the discriminant. I'm going to gently remind you that discriminant is b squared minus 4ac. That is the component of the quadratic formula that is underneath the radical. Okay. And problem number 26 has a small typo in it. These should actually both be the same variable. So I'm just going to say this is an x here, and we'll call it good enough. That was not supposed to be a trick question, so don't worry about it. All right, so let's do a little substitution here. My b value is -3 squared minus 4 times a is 9, c is 2. Now, I'm going to put this whole thing in the calculator all at once. So -3 squared minus 4 times 9 times 2, and I get a lovely value of -63. If I think about the fact that this would have been the value underneath the square root in the quadratic formula, trying to take the square root of a negative is not going to get me any kind of real solutions. So the answer is 0 real solutions. Okay, no real solutions when your answer here is negative. All right, if I slide over to number 27, I can't actually approach quite yet because it is not in standard form, and I need this thing to be in standard form before I apply the discriminant. So -2x squared minus 8x minus 8 equals 0. You could go ahead and divide everything by a -2 or a +2 or any of that stuff. You honestly don't need to, though. So I'm just going to go ahead and from here talk about my discriminant value. So b squared minus 4ac. All right, so let's see, -8 squared minus 4 times -2 times -8. I got a lovely value of 0 here. And 0 underneath that square root in the quadratic formula means that the plus or minus would completely disappear, and you would only be left with 1 real solution. So anytime your discriminant value turns into the value of 0, so the b squared minus 4ac equals 0, you have 1 real solution. All right, last but not least, number 28. Number 28 is in standard form already, which is great. So I don't have to do any rearranging. I just need to figure out what b squared minus 4ac is. Please remember that the a value is the number sitting in front of x squared. There is no number here because, well, mathematicians are lazy. And so that number we assume is a 1. All right, so -5 squared. Make sure that -5 is in parentheses. Please, thank you. If you don't, your calculator is going to lie to you horribly. I got the number 1. Now, that doesn't mean that you have one answer. It means that you have a positive value underneath the square root in the quadratic formula, and any kind of positive number underneath that square root is going to lead you to 2 real solutions. Okay? So in this particular set, 26, 27, 28, you saw all 3 possibilities for the discriminant. If your discriminant value is negative, no real solutions or 0 real solutions. If the discriminant is exactly equal to 0, you get 1 real solution. Any positive answer for the discriminant will get you 2 real solutions. Okay. Okay, last two problems. It's a throwback to what we did in the first unit dealing with domain. All right, so number 29, you're going to have to do two things. This root 100% has to stay positive or 0. Because it's in the numerator, 0 is totally fine. So we're going to start by saying that x has to be greater than or equal to -2. That's the start. Now, my denominator absolutely cannot equal 0. Well, the value that would make the denominator equal to 0 is if x equals 7. So this is the inequality part that I'm going to deal with, but as I work with this inequality, I need to make sure that this value of 7 gets thrown out. Now, I'm a visual person. It is in my nature, so I'm going to put these numbers on the number line. -2 here, and we want to be greater than -2. So shade, 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 which is great, except you would at some point have shaded over the number 7. So 7, we're going to throw a set of parentheses here to indicate that we are throwing 7 out. And then the equal to part here means we're going to have brackets here. So if I write out this interval, I'm going to start with -2 to 7. 7 gets parentheses, -2 gets bracket. Union, because this is going to pick up, bounce right over the number 7 to infinity. So this is your domain for problem number 29. Both parts of the fraction mattered. And the numerator mattered because it had the square root. The denominator matters because you cannot let the denominator equal to 0. Okay, so that's number 29. Last problem. Okay, last problem. So again, we're talking about finding the domain. First thing I want you to recognize, the numerator has absolutely no impact on the domain. This is not a root. So because this is not a root, my numerator can be any number in the entire universe. I don't care. I'm not going to worry about it. The only thing I have to worry about is I cannot let that denominator equal 0. Well, the only value that's going to make that denominator equal to 0 is 0 itself. All right, you just cannot let x equal 0. 0 squared is 0, so can't divide by 0. This one, if you want to draw the number line, you can. Basically, what you're saying here is x can equal, right? Your domain can be any number except for the number 0 itself. So our shading starts at negative, and that is a horrible infinity sign. Let's try that again. There we go. -infinity to 0, parentheses on both. Union 0 to infinity. So what we're saying is that we're going to start shading at -infinity, right? Shade, 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 jump right over the number 0, and then continue shading to infinity. So the parentheses here on the zeros indicate that we are skipping over that number. Okay, so again, 29 and 30, a little bit of throwback to what we had done previously in terms of domain. So hopefully this will help you guys get through your study guide information. If you do have any questions or concerns, reach out to me through Canvas, Remind, or direct email message.